Okay, so last time, what did we do? Can you please not talk while I'm talking? I can't think when you do that. Sorry, but thank you. Last time we were talking about how to reverse a vector. Change all the elements around. If they were going in order, now they're in reverse order. But it didn't have to be in order, right? It could have been 1, 4, 3, 2. We wanted to make it 2, 3, 4, 1. Yeah? Let's see how to do that here. So we came up with this strategy. We were like, okay, I can stop in the middle. I can make exactly size over 2 swaps. I won't go past the middle. I'll leave a middle element alone if it's an odd number of things. And I will swap first index 0 with the last element. That's the size minus 1 element, okay? Then I'll swap, if there's more to swap, I'll swap index 1 with v.size minus 2 element, okay? And so on and so forth, taking care to not go more than size over 2 swaps total, because if you swap for everybody, it's going to eventually just put it back to normal. We don't want that, okay? So are there any questions about what we did last time? Because now it's time to implement it. Let's do it. So let us initialize stuff, all right? Let's say this. We have some long vector. Let me, I don't know, let's just make it 1, 2, 3, 4, 5, 6, 7. And we want to swap everybody. We want to reverse this to 7, 6, 5, 4, 3, 2, 1, right? So a very long example, just to show that what we were thinking is going to ring true. It's going to do it right. Okay, so indices 0 through 6, this is my v, let's say. What I'd like to do is initialize my iteration variable to 0, and that will always be the left side, the left thing that I need to swap. Okay, I'll use I to keep track of the left index, and I will calculate using I the right index. Okay, that's going to be the trick. Because at the very beginning, remember that v.size here is going to be 7. We're going to iterate size over 2 times because of lovely integer division. So we're going to iterate, how many swaps do we have to do? It's going to be this one, 1, 2, 3 total, because we're skipping off that 4, right? That many swaps. And back to this, we're doing 3, right? And that is exactly 7 divided by 2 using integer division. 3.5, chop off the 0.5. That's how many swaps I need to do. So I need to iterate size over 2 times, I starts at 0, and each iteration, I'm going to swap index I, so right now it's 0, it starts at 0, with this index, size minus I minus 1, or if you want to think about it like we were doing here, size minus 1 minus I, because the first index you swap with is your last one, right? v.size minus 1. So maybe I could make this minus 1 minus I. That helps. Because at the very first time I is 0, and that creates the index size minus 1. Do you see that? Isn't that beautiful? That's the formula. So that'll have us swap these guys. Then we know how to swap using temporary variable and all that, 7, 1. Then we increment I, because we're doing it 3 iterations total. Now we're in our second iteration, I is 1. I will swap index I, so index 1, with index 5, but I can calculate it like this, using I. It's size minus 1 minus I. Now I is 1, right? So it's going to be size minus 2. That's 7 minus 2. That gets me my index 5. So as I grows, I take size minus 1 and subtract I. So the first time it's this one, second time is this one, third time it's this one. It's moving inwards from the end. Do we see that? Isn't that beautiful? Do we see it working? That is what we'll do. So then we'll swap index 1 and 5. That's how we calculate it. So this becomes 6 and 2. And then finally, for our third swap, we swap indices 2 and 4. So I is going to become 2, and then 4 is going to be calculated by doing size minus 1 minus I again. So I is now 2. So that's size minus 3. 7 minus 3 is 4. Those are my 2 indices I would like to swap the values at. So this becomes 5. This becomes 3. And we're done. There's no need to swap index 3 with itself, right? This is now a correctly reversed vector. Isn't that lovely? And remember to use your temp variable when you're doing the swapping. one thing gets saved away so that you don't overwrite it later. But you want to always iterate this many times, as long as I is less than size over 2 times, because that'll be, if it starts at 0, size over 2 times total. Okay? That's the beauty of integer division. Any questions about this algorithm before I implement it? It's supposed to say temp. All right. So let's do it. This is going to work no matter what. So vim reverse CVP. So let's do it with vectors. We like vectors. So I'll include the vector library. And let's make a vector. Vector int v equals the one I had in the slide. And so now I'm going to reverse v using a loop. We're going to iterate with I going from 0 to size over 2. Strictly less than size over 2, though, so it's size over 2 times total. For int I equals 0, I is less than v dot size over 2. Just like that, I plus plus. Maybe I can surround those with spaces if it makes it easier. But now this loop is going to iterate exactly size over 2 times. And that's what we needed. And every time we swap indices I and size minus 1 minus I. Okay? Does it make sense why I calculated it to be this, the size minus 1 minus I bit? Was that explanation good enough? Because now we just got to swap. We're good to go. So int temp equals one of the indices, so v at I. And then let's swap v at I. Make that v at, let's see here. How do I want to do this? Maybe I'll store into a variable the index that I want to swap with. So int index to swap with. That's going to be size minus 1 minus I. That's just a long thing to type here. So v at index to swap with. How about that? And then finally, v at index to swap with needs to become temp. That is the swapping algorithm. Okay? Any questions about that? What have I done here? Invalid operands. Type. Oh yeah, v dot size, sorry. I used my comment and I read it a little too closely. So that's our algorithm. Iterate from I equals 0 to, but going size over 2 times total. And then always swap your current index I with the other side of the vector. The index that's at the size minus 1 minus your I. Okay? And this is the swapping algorithm. Temp equals the first thing equals the second thing equals temp. We saved it away. Okay? So now, after this loop is complete, we have reversed our vector. And I can print it out for int element E in V, see out E in a space maybe. See out a new line after that. So in theory, we should see 7, 6, 5, 4, 3, 2, 1. Yeah, we do. Cool. Are there any questions about this code? What we did here? Are you happy with that? And this could be any size vector, doesn't matter. It could be even sized. That size over 2 accounts for it still. The temp saves away the thing we're trying to swap. So for example, let me draw out the very first swap here. So we were swapping the 1 and the 7, right? So I had it like this. Then I noticed I need to swap the 1 and the 7. Oops. I can't just say v at 0 is v at 6, because that would make this 7 here, and now they're both 7. I've lost the 1. The temp keeps me from losing things. So I put the 1 here safely. Then I can make this 7, and then I can make this whatever temp was. And that correctly swaps them. Any other questions? That's the code. That just gives you the other side of the vector. So, for example, we noticed that in the very first iteration, we want to swap index 0 with our last index. The last index was v.size minus 1. Yeah?
Okay, what is minus
I is our variable. And then the next time it was 1 and v.size minus 2. I is going to be the left side, the left index. So I will be 0, I will be 1. And then using I, it's always v.size minus whatever this is. v.size minus 1 minus whatever this is. So v.size minus 1 minus another 1. That's how you calculate the other side of that vector. Indices I and size minus 1 minus I. So when it's 0, size minus 1 minus I is size minus 1 minus 0, which is 6. When I is 1, we want to swap with this one, and we'll get that with size minus 1 minus I, because I is now 1, size minus 1 minus I gives us 5. It's just moving inwards from the end each time. Size minus 1 is the end, and then with each new iteration, we add 1 to I, and so we're going to move to the left, make it a smaller number, because I'm subtracting. 1 each time, though. Does that make sense? Cool. Any other questions? This is a fun little algorithm. That's a nice thing that we might want to do one day. Are we good to move on now? All right. So, oh yeah, question. Sorry.
How would this be useful in a program? How would this be useful in examples?
Like give you a real program that actually needs to reverse something. Let's see. Maybe you were given. Let me come up with a good strategy in my mind. Good scenario. I think prices might be useful. So say you make a company that tries to always find the best Amazon deal or something, and you come up with a list of all these cool products, and you want to show them off to your users, and you allow them to sort the products. So maybe you have functionality that knows how to sort by prices that increase, right? I showed you the sort function that makes the prices increasing. But the user clicks it again, and so they want it decreasing. So if you reverse that array of all your prices, then you can give it back to them on their web page. Does that make sense? Something like that. That would be an idea. But yeah, if you have... What's that?
I said, oh, I just like, that's a pretty use case.
Yeah, that's your use case. So if you have data, you're given to it, you're getting the data in ascending order, but you want it in descending order. Usually numbers are good like that. You might want to see the biggest thing first for some reason. You'd want to reverse. Any other questions? Because then I have a question for you. So let's see here. I don't think you have to put this on the written nice page. There's probably too much going on, but I want you to discuss as a group. Like somebody open up Paint or go on the server or something. See if you can write down how to do each of the following things in these bullets for both arrays and for vectors. Okay, so pretend you got an array sitting around somewhere, and pretend you got a vector. How do you access an element at a certain index? Because there's a difference, right? How do you initialize your array / vector to hold 1, 2, and 3? You have some options there. Pick whatever you like, but try and enumerate them all in your mind at least. And then finally, how would you create a new array / vector of size 10 holding 42 in every index? And this would be complicated, so just talk about how you might do this. Write English to say how you might implement it, or you can just write some what's called pseudocode, where it's like English plus code, like I'm going to do this 10 times kind of thing. Don't kill yourself. But
is that like the technical nomenclature that people use for like coding but kind of explaining English?
Yeah, it's called pseudocode. It's code-like,
Yeah.
but it's not any one language. That is the technical term. Yeah. So yeah, don't you don't need to write code for this. Just write pseudocode. Write English. It would be too much to write otherwise. So yeah, those are the things I'd like you to think about. I'll give you, I don't know, a minute for each, so 3 minutes total. So please discuss as a group how you might do all these things, and then I'll write down the way that I can come up with. There's plenty of options though. Yeah. Oh, let's see if it's letting anyone in. That would not be fun. Let's see if I can connect as my test student. So it is working for me. Did you maybe type your password wrong too many times? Oh, shoot. Okay, yeah, if you do it wrong too many times, it locks you out for 5 minutes. Okay, yeah. Try one more time, and then if it still doesn't work, I can just reset your password to be your username. Oh, sorry, let me show you the questions again. Excuse me. There you go. Here, I'll start the timer now. What's that?
It's like simple questions.
Yeah, if I ask you any, because you just learned about them, I won't write super hard ones. All right, so I guess it should tell you that it's wrong. Here, let me try and log in incorrectly. Permission denied, try again is what it should say. That means you're still locked out. So give it a little while longer, and then... Oh. Can you show me how you're connected? Take another minute and a half to discuss.
Every other website works except for the login for host community and Canvas. Because I'm on the laptop and it works. Yeah, I figured it was just a glitch or that people were using it at the same time. School started. I don't even have a day.
30 more seconds.
Every now and then, if I refresh it enough, and I wait long enough, it'll slowly load. But it won't actually let me access anything.
All right. I'm glad we're having some good discussions, but let's come back. Let's discuss as a group now. So there's a million ways to do all these things, right? Gosh. But there's actually only one way to do this one, right? So if you have an array, you can't say .at, right? You got to use the brackets. Go to the index I, please. For a vector, you could technically use this syntax. It works too, but I'd rather you use the .at because it'll yell at you if you try to go past the end. or before the beginning. So that's the standard way of doing those, but there's a million ways to do this one, right? You could just start off an array with that has nothing. It could be like int r of size 3 semicolon, and then fill it in with the accesses. Or you could be like equals 1, 2, 3 all at once, right? Same kind of thing for vectors would work. You could be like vector int v semicolon, and then you could push back a bunch of stuff. Alternatively, you could just say equals again 1, 2, 3. That would also work. Whatever you want to do. There's a million different ways to do that. But pushback only exists on vectors. For an array, you have to say either explicitly or implicitly that your array is of size 3 when you declare it, right? And then finally for this one, gosh, there's a million different ways to do it. Probably the easiest one is just to spell it all out, int r, right? If you're going to do an array, just make it like, okay, 42, 42, 10 times, something like that. Or you could do it in a loop. You could make an array of size 10, semicolon, and fill it in, iterate through indices 0 through 9, right? And put everybody in at 42. You could push back 10 times to an empty vector, the value 42. There's actually a secret thing that you could do with a vector. In one line. It's called the fill constructor. I don't know how easy that is to see, but it's this one, this weird looking thing. You can say, hey, give me a vector of ints 4, 100. For this one, you could say, hey, give me a vector of ints. And then you put parentheses like it's a function call. You say, I want 10 42s, please. And that fills it up for you. That's kind of cool. That doesn't work for arrays, only for vectors. This also works for strings, actually. Give me 10 C characters or something. So yeah, there's a bunch of different ways to do it. Hopefully we came up with some of these that I showed, or at least talked about them. Any questions about any of this? It's just syntax differences. But some ways only work for arrays, some ways only work for vectors, and I want to get you comfortable with the difference. Are you happy with that? All right, for my next trick, I want to talk about something called C strings. So in the C++ language, we've been using the string type, right, in the string library. We like those kinds of strings. Those I will lovingly refer to as C++ strings. There's a different kind of string called a C string that also exists because C++ has evolved from C. So it gets these pieces as well. We get the C library too, right? C stdlib, all that cool stuff, C math, those come from the C library. So we have C strings that are still around, and let me talk about those. A C string is just a fancy array. A C string is just an array of characters. So the type of a C string, it's not string, it's char bracket bracket. It's an array of characters. It's very simple, right, to make up a string. For reasons that we will get into later in this class, this type is equivalent to saying char and then a star. You haven't seen the star before, but either one, you see either one of these, just think C string right now, okay? Technically, this also means an array of characters. Very weird to think about, among other things. So, yeah, we prefer to use C++ strings, and we do that as much as we can, but sometimes we have to do C string stuff. If you want to use the C string library, there are some cool functions that only work on C strings, and then there's another thing that I'm going to show you a little bit later that forces you to use C strings as well. So, yeah, all a C string is a special kind of character array. That's all. That's all it is. The reason I say special is you can't just make an array of characters and say, oh yeah, that's a C string. Like HELLO. That's not the hello C string. Okay? There's a special character that marks the end of a C string. It's called the null terminator character. It's this \0, just like there's a \n, this is \0. It's ASCII code 0, and it marks the end of a C string. Marks, let me try and draw that a little bit better, marks the end of the C string. Okay? So this makes it a C string, it's HELLO, and then this special null terminator character, that's what it is. It marks the end of a C string. And also because, I mean, nobody wants to write their strings like this, those double quotes have secretly this entire time been making C strings for you. They just get up converted into a C++ string when you assign to one. But double quotes creates a C string. It creates this array, HELLO, with that secret character at the end as well. Okay? So you can say this, and it's exactly equivalent to the line above it. Char, stir, bracket, bracket, equals, double quotes, hello. That's a C string, shorthand for it. It's including that secret null terminator character at the end. And the reason it's there is so that all the library functions know when the string is over with. They don't know what the last character is normally, but now they do. Also because arrays don't know their size, now we have a special character to say when we're at the end. We know that that is the end of our array. That's why they did it. So yeah, stir in memory now is going to look like this. Stir, it's an array of characters with that special null terminator character at the end. It's got the H, it's got the E, it's got the L, the O, and that null terminator character. So even though you see when you write it out with this shorthand syntax, you see 5 characters that you typed, there's always an extra 6th character at the end. Okay? And C++, like it's all built in, it knows how to handle C strings as well, so you could totally say cout stir, just like this. That's the name of the string, don't include the brackets or anything, and it'll print it, just like it would print a normal C++ string. Okay? That's a bit weird and different, but are there any questions about it right now? That's what a C string is. It's a special character array that holds that null terminator character to mark the end, the very last character in it. Yes? It does, because you could make a string, you can make a character array that's huge, like size 100, and it's got extra undefined stuff out here. But if you go and print it, it's going to print all the characters up until the null terminator character. So you could save room for later, but make a smaller string. Does that make sense? That's what that is for as well. So you don't have to have this always be the last thing. It's just the last thing of the string. Any library function that takes a C string or prints a C string is going to consider the string over with whenever it sees that character, even if it's before. So if you want to just make this the string HE with some extra stuff at the end, you'll put the null terminator character right here, and then all the library functions will see the word he. It won't see the extra ones, they'll stop. That's a great question. Any other questions? All right, so let me just talk about this in code for a little bit. C strings.cpp. So let's make the string hello again. So char s bracket bracket equals, let's spell it out this time, H character, then the E character, then the L character, then L, then O, and then that null terminator character at the end, \0 in between single quotes. Okay, that's a C string. It's a special kind of character array. So you just say S. S is the name of the string. Okay? And then char s2 bracket bracket equals hello. That is shorthand for the line above. Much nicer to type it like that, right? For the above. And C++ knows how to print C strings. You could be like cout s2. And it's happy with that. Boop. And so it prints hello. Very nice. Down here. And we're on our way. Okay? Are we good with that? Because now I want to show you the library functions. Like, why would I teach you any of this if you can't do cooler stuff with it? So let me show you the C string library. All right? You got your C string library, and also C_std_lib has some C string functions in it. Okay? So here are 4 of them that I will show you. Do I want to type out all of them? I guess I do. So the first one I'd like to show you is called A2I. I guess A means string, alphabetic, I don't know, characters. 2I means int. So this will take a C string, convert it to an integer. Okay? This will be nice, and let me show you where that is. That's going to be, pretty sure that's the one in cstdlib. So let's go there. C library, cstdlib. Yeah, there's A2I right there. Convert string to integer. So it takes a char star, which is a C string, right? And then it gives you back an int. It gives you back the integer form of that string because there's a big difference, right, between 4 in quotes and the number 4. This takes the quotes 4 and creates the number 4 for you. Okay? That's what A2I does. So let me show that to you. So that means I need a string char S3, I guess. Let's make that have 42, the string inside of it. So that's not the number 42, it's the 4 character, then the 2 character, right? I can't do anything useful with it right now. I can't do math with the string. I can't get the 42 out unless I say A2I of S3. Okay, and to use that, I need to include. Okay, that was because I closed something. And to get that feature, I need to include cstdlib. That gives me A2I. Okay, so I can say A2I S3. That will create the 42, give it back, and then I can do stuff with that number 42 now. It'll have made the number for me. So times 2 or something, that'll give me 84. Does that make sense? That converts a string to a number, and then I can do number stuff with it. A2I takes a string, converts it to an integer. And so now this is the number 42. I can multiply it by 2. Okay, any questions about that? Again, this doesn't do what you want. A string is not a number. It's not even going to compile. Okay, so that's A2I. Hopefully that's self-explanatory. There's also in the string library, because any C string can be up-converted to a C++ string, there's an S2I function in the string library, the C++ string library, that you could use instead. Either one works. And then here are 3 more. The next ones are all in the C string library, I believe. So let's go there. C string. There's a ton of them. And the first one I want to show you is strcat. Interesting name. Where is that? There it is, concatenation. That's a very fancy word. It's called concatenation. It just means put together, bring together 2 strings. So strcat takes 2 strings, string 1 and string 2, and it adds to the end of the first one. That's why it's called destination here. It adds source to the end of destination. It updates that string. Okay? It appends a copy of the source string to the destination string. So it's essentially the plus operation on C strings, but a little weird because it modifies the first one. So you can think of strcat S1 and S2, that call to be kind of like equivalent to the line S1 equals S1 plus S2 in C++ string land. Okay? That's essentially what it's doing. And so this is one of the cases where you need extra room in your S1 for whatever you're putting at the end of it, for that S2, right? So you can't just have a string that's size 5 and all those 5 characters being in use. You got to make extra room for yourself. The first string better be big enough, better have some extra room at the end of it, because it's just an array at the end of the day, to hold the rest. Okay? So this will make sense with an example, I think. So let's make, I don't know, char S4. That'll be like high space. And then I'll make char S5 mom exclamation point. So this will eventually say hi mom. But I don't want to call strcat right now. Strcat S4, S5, because that's going to put mom at the end of this array doesn't have any room at the end of it, right? There's no room for an extra 4 characters, right? Can't do it. So, what needs to happen, and strcat, by the way, lives in the C-string library, C-string, now it exists. I need extra room at the end of S4. So here's what I can do. I can say, make me a character array called S4 of size 50, but just initialize the first bit of it to be the string high, and then the null terminator character in index 0, 1, 2, 3, right? So I'm only using the first 1, 2, 3, 4 indices because the null terminator character is being used there implicitly, but I have extra at the end. So there's room to place more characters after S4. Does that make sense? So I had something like this. S4 was looking like high, space, null terminator character, but there's 50 indices total. I just filled in that much. There's extra room over here, okay? Up to index 49. This is index 0. Does that make sense? And so now I can call strcat. That's going to set S4 to be S4 plus S5 in C++ string land. And so if I print S4 now, it will have grown. And so now it says, hi, mom. And there's still extra room at the end of S4. There's 50 characters that it could hold. But you got to watch out and make sure that there's always room for that null terminator character as well, because that needs to go at the end. Okay, any questions about strcat? Just interesting little function. Even though a C string is an array, and arrays in general don't know their size, strlen, a function that returns the size of a C string, can be implemented very easily. It just looks for where the null terminator character is. That's such a hard word for me to say. And that it just counts the number of characters before the null terminator character. That's how big the string was, right? So strlen gives you the string length. Strlen of S2, that's the hello on line 8. There's 5 characters. It's just looking for the null terminator character. It doesn't count it, though. This does not count that character. The number of real characters in the string is what it gives back. It doesn't count \0, the null terminator character. Okay, that's strlen. It's pretty cool, an array that knows its size, kind of. At least the size of the string that's inside of it. Are we good for the last one? The last one is called strcomp. String compare. They really like their 6-letter function names in the C library. This one compares the strings S1 and S2. Okay? So it's giving you back the dictionary, or it's trying to check for which one comes before the other in the dictionary, just like for C strings. But it does it in a very weird way. So you gotta watch out for this if you use the string comparison here. Where is it? Strcomp. String compare. So it takes 2 strings, and it gives you back an integer. Just so weird. What it gives back is if the first one, if the string that came first comes before the second one, so if S1, you call it like this, and S1 comes before S2 in the dictionary, strcomp is going to return a negative value. You have no control over which negative value, but it's going to be a negative value. So that's that. If the strings are exactly equal to one another, then string compare gives back 0, the number 0, you're guaranteed, which seems like false, right? But no, it means they were equal. And then if it gives you back a positive number, that means that S2 should have gone before S1 in the dictionary. Okay? S2 is the smaller string. It returns a positive value, an arbitrary positive value. Okay? What it's really doing is it's comparing ASCII codes a character at a time, and if they're ever equal, it just continues, looking for the first one that's different. And so it's going to do something like, let's compare the string AAB to AAA, and then it's going to subtract Like, it'll notice that the two A's are the same, then it'll subtract this ASCII code from this ASCII code, and it'll get a negative number, and that's what it returns. So you know it's smaller. You don't really need to care about that. You're not implementing it. You're just using it. But that's what you get back. It's very odd. Something like that. A lot of times it just returns -1 and +1, but you have no real control. That's up to the library implementer. So, cout str comp of ABC and BCD. That should return a negative number, right? Because ABC comes before BCD in the dictionary. What about BCD and ABC? This should return a positive number because BCD is bigger, right? It comes after ABC in the dictionary. And then finally, if they're both the same, it'll return 0. So I get -1, +1, and 0. Lovely. So that's string comparison. Hopefully you never have to use this, but now you know about it, if you do. Any questions about this or any other bits of the C-string library? All right. Because, I mean, why would you use any of these is probably your question in your mind right now. Like, well, I can just use C++ strings. Everything makes so much more sense. There is one time where you are forced to use C strings, and that is for something very useful. It's called command line arguments. Okay? So when we run our programs, we always just say / the name of the program, right? That's the one that we've made. We run it like that. But you've been running other command line programs like this. You've been saying G++, the name of the file, -o, the name that you want it to be called. You've said CD, you've put a tilde after that. You've put stuff after the name of your terminal command, right? Your programs are also terminal commands. It's just another program, right? So why can't we do the same? Why can't we say / name of our program, put 42, put high, and like be able to access these things? There is a way, okay? And the way is called command line arguments, okay? And the reason it's called command line arguments is because you like pretend that the program is a function, kind of, I guess. And those are the arguments that you're giving it. They're all space separated when you're on the terminal. So that's the metaphor. You pretend, I guess, that prog is a function and you're calling it. Okay? So our program secretly is able to see everything that we give it on the terminal after its name. We just haven't tried, right? It's not getting anything right now. So I say /C strings. It'll run if I say hi, mom, 42, blah, blah, blah. It still runs just fine. It does have access to these, though. We're just not accessing, which is kind of cool. Let's gain that ability. I think you would agree that that's pretty useful. Then you can make your own CD command, something like that. So, okay. The secret is the way we define our main function. Right now, we're saying this, okay? And this is supposed to be prog 42 high kind of thing. So the way that we're declaring our main function, the way that we're defining our main function right now is int main, parenthesis, parenthesis, then we do stuff. I've shown you enough documentation pages where you see things that look like this, but there's stuff inside of those parentheses, right? You can put stuff in there. Your other option for a main function is this. It has to be exactly these types. You can name them. You can name the variables whatever you want, but it's a weird looking 2 type. So you could say int main, and then you could give an int. It's called a parameter. Int, and it's usually called argc for a reason I'll talk about. And then you could say char star argv bracket bracket, which is extra confusing, I'm sure. But these types have to be like this. This one, the first one has to be an int. The second one has to be a char star array, which is weird to read, I know. But you can name them whenever you want. Usually, though, people call them argc and argv. Okay? So let's think about these things. Gosh, what do I want to say first? So here's what they stand for. argc stands for argument count. Count. Okay. That's the number of command line arguments that your program was given. And then argv stands for argument vector. Cut them some slack. These were the C people. Vectors didn't exist. C++ didn't exist. It's just an array that they called a vector. Arg vector. Okay? So, yeah, argc will tell you how many things you were given. So if you run your ./prog with 42 and high, argc will be set to 3 because the name of the program counts for some reason. So that's what that one will be. And then let me show you what then argv stands for argument vector. Let's talk about the types now. So argc is an int, that's how many arguments you're given, and argv is a little weird looking. How do I want to do this? I'm going to use colors. argv, if I can spell it, it's an array of C strings. An array of C strings, and I'll use colors for those things. So this part means array, right? This part right here, that means array. Array is an array of, and then char star means C string, right? C strings. That's what it is. And with an example, it'll make more sense, but that's what the types are, and this will be what they're set to, okay? Are there any questions before I give you an example of this? This is very weird, I know. So you have a second option when you're making a main function. Say int argc char star argv bracket bracket. If you want access to the command line arguments. We've just been throwing them away, saying I don't need them. Now we can take them. Okay? So let's make a program called, I'll try and have it line up with my little screenshot back here. Let's call it command line args.cpp. Okay? And let's print them all out. So, gosh, how do I want to do this? First of all, the arguments are all space separated. You can put as many spaces as you want. So if I say ls -a, that's the same as saying ls space 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 dash a space space space. It's still seeing just that one thing. Space separation, though. You can put as many spaces in between as you'd like. And here's what happens. When you run your program like this, you say ./prog 1, 2, hi mom. They're all space separated, right? This is how you run your program. What is going to happen to argc and argv is the following. argc will be set to 5 if you run your program exactly like this, because it counts how many space-separated things are there, including the name of the program. So 1, 2, 3, 4, 5. argc will be set to 5. That tells you how big the argv array is. argv will be set to an array of C strings. You're forced to use C strings here. They're going to be every single command line argument, including the name of the program. So index 0 is the ./prog. That's this. It's taking all this and space separating it, parsing it all out. Index 1 is the 1, index 2 is the 2, index 3 is the hi, index 4 is the mom. Okay? And remember, these are all strings. So it contains the text of all the words. It's not the number 1, it's the string 1. Okay? That's what argv is going to be set to. So you're able to get this array, see how big it is. That's all you need to know to figure out what's there. Then you can go exploring. You can look inside now. You know the last index. Does that make sense? So, yeah, let me program this for you. Let's make a program called command line args.cpp. So instead of saying int main parenthesis parenthesis, I'm going to say int argc char star argv bracket bracket. All right, so argc count, that stands for argument count. It's the number of command line arguments. Okay. argv again stands for argument vector. It's just an array though. It's the contents of the command line arguments. It's the actual strings as C strings. Okay. And so the type of it's going to be an array of C strings, because you get one C string for each argument. Okay? So let's do this. Let's print out what we got here. So argc, when we run this program, is going to be set to the number of command line arguments, including the name of the program. That always counts as 1, so it'll always be at least 1. Print out argc, and then let's iterate through argv. I know how big it is. That's what argc is telling me. It's the size of that vector, or that size of that array, excuse me, of argv. So we can iterate. For int I equals 0, I is less than argc, I plus plus. Those are all the valid indices. Cout, oops. Cout, argv at index I contains argv of I. I can index into my array of C strings, right? That's an array. And then at each index is another C string, and so I can print each of them out, just like that. I hope that makes enough sense. And then return 0. That's the program. Let's see if I can give us some room here. But that's really it. So 2++, command line args, -o, command line args. And so now I can do what I was doing on that slide. I was saying stuff like / command line arguments. I can run it as we've run it before, just by itself, hit enter. argc is going to be set to 1. There's only one thing I gave, the name of the program. argv of 0, so that's the only valid index. That contains the string that is the name of the program. Okay? But now if I rerun the program with hi, space, 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 42, space, 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 I don't know, mom, etc. 1, 2, 3. Here's what we get. There are 7 command line arguments, right? 1, hi is the 2, 3, 4, 5, 6, 7. So argc is set to 7. I have indices in argv now of 0 through 6. The name of the program is the first one. It's all space separated, then the hi, then the 42, then mom, then 1, 2, 3. That's what argv is getting set to, and these are all strings. These are all C strings. If you want the number values, you got to use A to I, for example. Okay? Any questions about that? That's what you're getting back. That's what you're gaining if you use a main function like this. That's how you use argc and argv. Are we good for a more reasonable example? You ready for that? Something that you might actually want to do. Instead of just printing them out, let's use them for something. Okay? So for my next example, let's use our command line arguments to draw just a square. We know how to do that with a nested loop, right? So let's say something like, let's make a program called draw square. We'll compile it. We'll try to run it like this. / draw square of size 5, right? And so the number that we get will be the size of the square that we want to draw. We don't have to ask the user for anything. They gave us that number when they ran the program. That's kind of cool. So let's talk about that. So I want to run the program like this: / draw square 5. So there's command line arguments here. That's how I want to run this program. So let's do this. Define my main function in this new way, int argc, char star argv, bracket, bracket. And so now I want to draw a square of a certain height, right? Int height. Where is that height when I run the program, right? Where am I getting that? It's in argv, isn't it? Because if I run the program like this, what will argc be? First question. If I say / draw square space 5, enter, what is argc? For this example, it was 5. What is this example? It's 2. Very good. There's only 2 things there. So argc is going to be set to 2. Argc, for a correct run of this program, we only want the user to give us one number. So argc should be 2. That is required. Then, where in argv is this 5? Which index? Again, here's the example argv for this program. Let's run. Argv of your answer here holds the width. Or maybe a question mark holds the width of the square. So if I run the program like this, argv is going to be set to the name of the program first, and then the 5. What index is that? Yeah, it's just 1. This is 0, this is 1. Very nice. So yeah, it's really just all arrays. It seems a little weird, but we are slowly getting it. Oops. Give me an eraser, please. There we go. So argv of 1 holds the width as a C string. Right? This is the string 5 right now. So I can't just say argv of 1. I have to convert it. This is the string 5. I want it to be the int 5, so I use the a2i function from cstdlib. All right? So remember to convert from a C string to an int. Don't forget that. And then once I have my height, or I guess it should be called width, right? Either one, width or height is the same because it's a box. I can draw my box. For int I equals 0, I is less than width, I plus plus. Then the same for j, right? Nah, darn. There. Then I'll just draw my box, one character at a time. So there's a star and an endl, and that should draw a box, right? But I got the width not by asking the user and getting that value in through cin. I got it from the command line arguments before the program was run. It was the terminal giving that width to the program, which is pretty cool. So let's compile this. Oh shoot, I had to run it like this, right? Draw square 5, draw square 4. And I can put as many spaces as I want over here. It'll still go in argv1, 3, 2, etc. Okay? Draw square 42. It's very large. Draw square 5 though. Works just fine. So are there any questions on why this program, run like this on the terminal, creates this exact box? Am I good with that? Because I already did it, you can run this program incorrectly. You could say draw square 5, hi mom. We should probably disallow that, right? Like this is an incorrect run of the program. You should only be giving me 2 arguments, just the name of the program and how big you want the square, right? I can also give too few, and that actually is a runtime error because I'm trying to access an index into an array that does not exist. /draw square is trying to go into argv of 1, but there is only argv of 0. That gives me a runtime error. That memory doesn't exist. Oh no. So let's guard against that. Okay? Let's ensure that the user gave us the right number of arguments. If they didn't give us exactly 2 arguments, let's stop the program. Okay? If argc is not 2, as it should have been, then let's yell at the user. Let's be like, must run with a single number, exclamation point, new line. One really cool thing that you can do is you have exactly how they ran the program in your argv, right? You have their /draw square or whatever they called it, right? Because you get that, and in your 0th index, you have exactly what the user typed first. So I have /draw square sitting in argv of 0 right now. I could say, hey user, you should have run me like this. Cout usage. argv of 0 is however they ran it, right? That was their /draw square, or whatever else it was. Could have called the program /prog, it'll still get that. argv of 0 You should have run me like this. Argv of 0 and then space and then a number where n is a number. Isn't that cool? And then we don't want to continue, so we'll stop the program. I can return 0 right now, or I've already included cstdlib, might as well use the exit function, which stops the program. Okay, so if I give something wrong now, it won't allow the program to continue. So now I can say draw square 5, it still works, but now I can say draw square without anything, and it won't give a runtime error. It'll say, it'll hit here, it'll hit this if statement. You must run me with a single number, usage /draw square n. It got that from argv. I never typed anywhere in the program /draw square. It was just getting that from argv. And if the program name was something else, let me rename draw square to prog, /prog. It still gets that name in argv of 0. That's how the terminal's giving it. Isn't that cool? Let's move it back. And so it'll complain if I give too few or too many. It's got to be exactly 2, please. And then, if I give the right amount, it works. Okay? Any questions about this program? Doing stuff that is a bit new. It's getting information from the terminal right before we run the program. That's who's setting up the argv and argc for us. I hope you notice how they all play nicely together. Okay? So yeah, I think let me check my notes. In the last little bit of class, I want you to try something. It'll be kind of cool. So get together as a group. You can talk about this in pseudocode or try to code it even. I'll give you like 5 minutes. But I think we got some time. So here is my challenge for you. Write a program that takes command line arguments, right? So you're going to run it like /prog with blah and like hi 42 or something. And then what I want you to do is give back everything but the name of the program, but do the following to every word, every command line argument after the name of the program. Capitalize every letter. You can use CC type for that. And then shift every digit. Every 0 should become a 1, 2 should become a 3, all the way to 9 becoming a 0. Okay? So this should be, you should print out, when you run the program like this, all caps blah, and then all caps hi, 5, 3. Can you try that? I'll give you like maybe 4 minutes to get started on that, and then I'll show you how I might do it. But that will prove that it's working. Okay? And let's see, what can I do to help you here? Let me give you the text of this program right here. Can't be very large, but there's me printing out all the command line arguments. Here, I'll put this up here somewhere. There you go. Take your command line arguments and do the following. Capitalize every letter, shift every digit over. See if you can do that. And ask me questions if you're confused. There's definitely an easy way and a hard way to shift those digits. Try to think of the easy way. The hard way is a bunch of if statements, right? CC type is your friend. Remember that to upper will always convert anything to uppercase. You can just give it a number. It'll keep it the same number if it's not already lowercase. So that's pretty easy. This is a good little example, I think. I got a text message saying that our power might be shut off. I wonder if they'll shut off the school's power if it comes to it. But we ended just in time. If they do. One more minute, and then I'll give you my answer. All right. That is my timer. Very soft because I opened it right as it ended. Let me show you how I might do this. So, let's see here. What should I call this? We're capitalizing and then shifting, right? So capitalize and shift. That's EVP. So here's how I will think about this problem. Int argc, of course, char star argv bracket. Here's what I would like to do. I need to go through every string starting at argv1, right? argv0 doesn't count. I don't want to include that. Starting at argv1 onwards, go through every argument, command line argument. So for int I equals 1, I is less than argc. Those will give me all the valid indices into argv that I care about changing or looking at least. And then, all right, so this is me iterating through all the arguments, all the command line arguments after the name of the program. So now I'm accessing them, right? I can say char star s equals whatever that one is, argv of I, because a char star is the same as a character array. I unfortunately can't say this as you might want to. I have to use the star for a very weird reason that we'll talk about later, but you didn't have to do it this way. You could just said argv of I all over the place. I'm going to use s all over the place now. And now I want to go through every character of this particular string. Yes? Every character of this particular string. So it's just an array. I want to go through every index of that char star array, of that char array. For int j, let's see, process, let's say this, process every character of S. So I need to iterate through every character. For int j equals 0, j is less than, what's the last index that I care about of this string? It's at size minus 1, sterlen of S, j++. Process every character that is not the null terminator character. And so I need the C string library, if I want that. And so now, S of j is my current character of my current string. So we're in here now. What do I need to do to it? I need to capitalize it. And I can call toUpper, and it doesn't matter if it's not already CC type. I can say toUpper right now. It doesn't matter if it's a digit, a lowercase character, an exclamation point. toUpper won't touch it unless it's a lowercase character. It'll just keep it the same. So I can say S of j equals toUpper S of j. This only changes S of j if it's lowercase. Then it'll make it uppercase. Otherwise, it keeps it the same. Now, I need to, if it's a digit, change it. If S of j is a digit, shift it. Okay? This is where things get a little weird. So where is that? Let's go to CC type. Technically also part of the C library. We have an isDigit function, which is nice. It'll give us true if the character that we're asking about is a digit. So if isDigit S of j, that'll return true if S of j is a digit character. Now I want to touch it, if that's true, right? Now the question is, how do I get the next digit? Right? If it's a 0, I want to make it a 1. If it's a 2, I want to make it a 3. If it's a 3, I want to make it a 4. Now we can do ASCII arithmetic. So this is not the world's easiest question, but it should get you thinking, I hope. So here's the ASCII table. Whee! Here are the digits. They're arranged one after another. So if I add 1 to the ASCII code for the 0 character, it'll give me the 1 character. If I add 1 to the ASCII code for the 1 character, it'll give me the 2 character. So in pretty much every case but one, if I say S of j equals S of j plus 1, that's the next character in the ASCII table. It'll make the 0 the 1, the 1 the 2, the 2 the 3. Does that make sense? Interesting. And then finally, I've worked on S this whole time. I am now done with S. Let's print it out. Way down here. See out S. And so that's my loop. There is something currently slightly wrong, though. I think I just barely told you about it. Do you see it? It's going to work right for my example, though. Capitalize and shift, blah, high 42. Or did I do it backwards? No. So this will print all caps blah, all caps high 53. What will it do wrong right now? Do we see it? There's one digit it won't do the right thing to. It's 9. If I say high 99, it's going to say high, all caps high, colon, colon. Because the colon is the thing after the 9 in the ASCII table. Whee! I wanted a 0. You see that? I wanted a 0 there. So I guess the easy way to fix that is, well, if S of j is a 9, S of j is a 0. Otherwise, do it this way. So there's a corner case there that you got to watch out for, but it should work. 99, 42, 00, 53. So definitely study this code. It's a good conglomeration of everything we've been learning in this class. So command line arguments, C strings, nested loops, string stuff, ASCII, char stuff, all that glorious goodness. So any questions about this program, this challenge program that I gave to you? I would not dream of asking you to do something like this on a test. That would be very evil. But this is a great practice, I would say, for the exam. Are we good to keep going? And by keep going, I mean stop. Because that is the end of these slides. We made it. So let's see here. Let's get this back to normal size. We've all said that we're here, right? Can I stop that? Yell at me now. I heard an O, so we'll give you a minute. But yeah, no new lab this week. I'll release a new lab next week. And remember that there's an exam next week as well. So yeah, that's all I have for us. I'll stop recording.